All right, today's lesson is going to be on the inverse square law. Now, this is going to sound like a lot more confusing than it actually is. It's actually quite easy. So if we bring out a calculator, and if you have a graphing calculator, you can actually pull it out and put these equations in, and we can actually look at some of these on this. This is going to seem like a lot of math, but there is a physics side to this. So if we just put in y equals x, you get this line, a nice straight line. We call this a linear representation, and it's just a nice, line. Nothing special there. If you do y equals negative x squared minus 4x, you get this negative parabola going up and down. These is nothing new. You should have seen these in your math class. But if you also put in these equations, you can have other equations, such as 1 over x. This is what we refer to as an inverse equation, and it gives you this nice one with an asymptote right at 0. But then you have ones which we call our inverse square, meaning it's 1 over x, that's the inverse part, and then the square, it means it's squaring the bottom. And you're going to get an equation like this, again, where you have an asymptote located right at the 0 line. Well, what do these graphs show us? Well, this is actually telling us what we call an inverse square relationship. That as we get further away from something, that's going to decrease not by a little bit, but by a lot, by the square of it. You're going to decrease by the square of the distance. So the inverse square law says that the force of an object, so in this instance, we're going to say gravity, is going to decrease exponentially as we move away from the object. So from distance from the center of the Earth in this graph. So if we're 1 radius unit away from the Earth, gravity is this one. If we're 2 radiuses, we're not just twice as less or half as much, but we're actually going to be half squared or a quarter. If you're at 3 times as far, you're going to be 3 squared or 9 times. 4 squared, 16 times decreased in your gravity. 5 squared, you're going to be at 25. So you're going to have this exponential decrease. So the force decreases by the exponentially as the further away you go. This is what we refer to as the inverse square law. Now, there are many things that obey the inverse square law. The Coulomb's law, we actually saw this earlier, and it is K times Q1 times Q2 divided by R squared. Notice that R squared is on the bottom. This means that this is an inverse square law, meaning that if you have one charge, let's say an electron, and a proton, as you get further and further away, the attractive force that pulls them together is actually going to decrease exponentially. Gravity is the same way. As one mass and 2 masses are close to each other, as you move away, that force will exponentially decrease. This also can be found in distant relative intensities from a distance. Sound is actually this way. As you're close to a sound object, if you just double the sound, you actually are going to decrease the amount of sound that hits your ears by not just double, but by 4 times, by tripling it. So this is kind of like if you go out shooting a gun and shoot a shotgun right next to your head without hearing protection, you're not going to hear very long. Double the distance, it actually decreases by 4, and if you triple that, it's 9 times less. And if you just go out to 10 times distance from there, you are going to decrease that sound by 10 squared, or 100 times decrease. This is the reason why headphones are becoming dangerous. As you plug in those your headphones into your ear sockets, it's closer to your ear and it increases that overall sound into your ear and can damage it. Radiation level, same thing. If you're close to a radioactive source, just doubling the distance will decrease it by a quarter. Increasing it by 10 times, you can decrease the overall radiation effect by 100 times, or 10 squared. So in this one, the universal gravitational equation is this. Now we're not going to deal with this equation very much. we're going to deal with it in the next unit when we talk about it in numerics, and we'll plug in this big G and we'll actually do the math. In this unit, we're just going to place it into this, where the force is related to the mass times mass over distance squared. So, gravitational force and distance can be characterized as an inverse square relationship. So, if the force is doubled, what will happen if force is doubled? Well, that means if you double the distance, that's going to be double squared, or 1/4 of the total amount of force. But mass is a proportionality, because it's not being squared, and as you double the mass, you double the force. So what happens if if mass 1 doubles? It just doubles. What happens to mass 2? If you half mass 1, you half the force. So whatever you do to mass, you do to the force. So what happens if you double 4? Well, you put a 2 in front of the mass 1, a 2 in front of the mass 2, so 2 times 2 is 4, so you 4 times the overall total amount of force. This is referred to as a linear relationship. So let's go through this. What happens if you force between the two objects if you triple the distance between each mass? So triple the distance is going to be the distance, so that's going to be squared, and it's going to decrease. So you're going to have triple squared, or decrease it by 9. What happens if you half the distance between an object? So you're bringing them closer. So we know that that's going to be increasing that. So that's going to be 1/2 squared, and it's going to decrease. It's going to go, so that's 1/4. So half squared is 1/4, and that's going to become stronger. So it's actually going to increase it by 4 times as much. Now, if you double the mass 1, you double the force. That's because they're a linear relationship. Now, what happens if you do 2 of the masses? Well, you just, again, quadruple mass 1 and mass 2. So you're going to have mass 1 has a 4, mass 2 has a 4, so 4 times 4, and that's going to be 16. So you increase it by 16, again, a linear relationship. What happens if you fourth the distance, half the mass 1, and triple mass 2? So this one, you're going to kind of write it out. It would be easiest if you write it out. So let's do the easy one. Half of mass 1. So that's linear, so you just half the force. Then you'll triple that mass 2. So that becomes 3. So you have you have the half times the 3, so that becomes 3/2. But then you have to then add in your distance, which you're quartering, and that's going to be, distance is squared, so that's going to be 1/4 squared, so that's 16. So you should have a 3 on top and a 2 on the bottom with a 16 on the bottom. So that becomes 3 over 32. So 3/32 as strong. So if you have any further questions, please ask your teacher.